Hi everyone, and welcome back. So we are continuing our journey to really know how to solve systems of equation. Just as a reminder, we briefly in the previous videos kind of talked about the use of this, the different applications, and then the method of graphing. So just as a reminder, remember systems of equations are equations where you have two or more functions or equations graphed together on the same coordinate plane. And you would essentially be looking for that point where the two intersect. So now we are going to go through a method that is a bit more algebraic in nature. We're doing a lot of plugging in. Really, the key thing to be successful with this method is to be able to organize your algebra work and just kind of keep everything in a very logical, organized fashion. You'll be good to go. So go ahead and grab your pencil and paper. I'm going to write down this system that we have here so you all can see that we have our system. We have y equals 3x minus 2, and we have x minus y equals 4. So first thing I want you to think about is how are these two equations kind of different from the equations where we graphed everything? And these were the equations from the other day. So if you're thinking, one main thing that is different is that these two equations are in different forms. So this first one that you see, the y equals 3x minus 2, is in slope-intercept form. And then this second one right here is in what we call standard form. And so when you are choosing the method of substitution, you typically want to use this method when one variable is already solved or by itself. So it could be x or y, so x or y. So when one variable is already by itself or already solved for. So you will see in this problem that I have set up here, our y value is actually already by itself here on this side. So we can kind of use that to our advantage. So what we would do for substitution is to kind of look and say, okay, well, y is equal to 3x minus 2. So I'm going to take that fact and I'm going to actually plug that expression in for y in my second equation. So let me go ahead and write that over here so it looks more organized and neat. So x minus y. Now again, we're replacing y with 3x minus 2 because again, they're the same variable. So we're going to go ahead and just replace it. So we're substituting in. So I'm going to put 3x minus 2 in parentheses just because that shows me that that is one expression. Once I plug it in, I'm now working over here with my equation. So the first thing I need to do is kind of simplify all this stuff that's going on here. So I'm going to go ahead and distribute the negative sign because this negative on the outside of this parenthesis means we have to multiply up everything inside the parentheses. So we would have x. So a negative times 3x would be a negative 3x. A negative times a negative 2 would be a positive 2. And then, of course, we have equals 4 over here. We don't want to forget about that. So now, this looks way simpler. There's not as many symbols floating around. We're going to just follow what we know about solving for equations. So the first thing we should do is look at our equation and see if we have any like terms that can be combined. So take a look. Do you see any like terms that can be combined? Yes. If you're saying yes, you are good to go. So we see that the x is here. This x and negative 3x, they are like terms which can be combined. Remember, like terms are when your variables are the same. So x minus 3x, so that means 1x minus 3x, we give us a negative 2x, right? Then we have a plus 2 equals 4. And I'm going to go ahead and just take a look and see, okay, let me go ahead and solve for this equation. So remember, we're going to use our inverses. Inverses mean opposite. We're going to use our inverse operations to undo everything. So for our inverse operations, let's take a look. So I'm first going to go ahead and subtract 2 from each side. So these cancel out. 4 minus 2, that's simple enough, it's 2. And then our negative 2x, that's going to actually come down here in our equation, and we're just going to keep rewriting. Then the next step, we have negative 2 times x equals 2. So what is the inverse of negative 2 times x? Well, the inverse of multiplying is division, so I'm going to go ahead and divide by negative 2 on both sides. So I get that x equals 2 divided by negative 2, negative 1. So we have our x variable, which is super helpful. Remember, the goal of this method or of this topic is to find that point, that break-even point where your two variables intersect. So if we found out that x is negative 1, remember, we need to get both an x value and a y value. So we've got negative 1, but we are still missing that y value. So I want you to think for a second, how could you possibly figure out what the y value is? Yeah, we could go ahead and we could take this x, this negative 1 that we just figured out, and let's go ahead and use one of our equations already given to us. So now I'm going to encourage you to use the equation that you're looking for. So in this case, I am going to use the y equation. I'm going to take this y equation because it says y equals 3x minus 2. And I'm going to go ahead and plug in this negative 1 for x, right? So y equals 3 times negative 1, because we're plugging it in, minus 2. Now I'm just going to follow my order of operations. So we'll do multiplication first. 3 times negative 1, right, is negative 3, and then minus 2. So be careful here. So negative 3, a negative number, minus a number. Negative 3 minus 2 is going to be negative 5. So simple. So now what does that stand for? That's our y value. So the point where our equations will have the same output, or they will match, is going to be the point negative 1, negative 5, and that would be our final answer. So if you feel confident in this process, you definitely can pause or stop or continue working and just start going through your practice problems. Again, to recap, the key points here would be first to look and see if this is a system that you would want to use substitution for. If one of the variables are already solved, use that. You'll be good to go. And remember, just keeping your work organized. I always like to work vertically versus horizontally. It helps me keep everything organized. If you need some more help, stay on. I will do another example. Okay, so we're going to go ahead. I'm going to show you a little bit more complex of an example. It has a little bit more variables, a little more things going on in it. So again, I look at my system and I see that substitution is a good method because we have our second equation here already solved for y. So remember, the first step is to take the variable, in our case it's y. I'm going to use boxes to show you that they're the same. And I'm going to plug in or substitute negative 2x minus 3 into that y equation, or that y variable. So I'm going to go ahead and use the first one. So 2 times y, remember y is negative 2x minus 3, and I have equals 2x plus 12. So really the first step is just copying everything down again accurately and making sure that you are ready to roll. All right, so I'm going to change my color here. So I've substituted my work, right? So I'll write, substitute variables, that's my steps here, and expressions. Okay, so now step 2 is going to be to go ahead and simplify everything that you can simplify. I'm going to do that in blue here. So I'm going to distribute this 2 times negative 2x is negative 4x. 2 times minus 3 will be a negative 6. And then 2x plus 12, well, that's simplified as much as we can get it, so, we'll be okay. I'll switch again. Let's go ahead and you see we have variables on both sides of the equation. So we want to get our variables to the same side. I do prefer to work on the left side of the equation for some reason, just kind of how I operate. So if I want to move this 2x to the left side, I have to subtract it by 2x. So I'm going to move that over here with the variables from the same side. So I'll get negative 4x minus 2x, negative 6x, right? And I have minus 6 equals 12. And now I want to get my numbers to the same size, so move those to the right. So minus 6, if I want to move it, do the opposite, add 6. Keep it nice, balanced, neat. All right, so now I've got negative 6x equals 12 plus 6, 18. And now let's go ahead and, how do we get rid of this negative 6 times x? How do we get rid of that negative 6 that's attached to it? Right, use the inverse, and we're going to divide by negative 6. So look at x equals 18 divided by negative 6 is negative 3. So here is our x value. Very nice, very simple, works out pretty cleanly. Don't forget that negative. So we have solved for x, right? So now our next, so I guess that was step 2, was to solve, right? Solve for your first variable, which, we did here. Our first variable was x in this case. Doesn't always have to be x, it's only up to you. So now our third and final step is to find your second variable. In our case, it's the y. So I want you to think, take a look. Last process we did, we used the y equation. I'm going to do the same thing here. So I see that y equals negative 2 times x minus 3. Well, do I know what x is? Yes. If we're looking for y, we don't want to plug anything into y, so we're going to figure out what that is. So negative 2 times negative 3 minus 3. Negative 2 times negative 3, positive 6, and then minus 3. So y equals 6 minus 3, and that gives us 3. So our final answer, our final ultimate solution will be the point. Remember, it goes x, y, negative 3, 3. And this is the point where they would match our two graphs. You can always check this by plugging your answers back in and seeing if you get the same output, if you get the same matching point. You could always graph your equations. If you want to look at slope-intercept form, convert them, you could do that as well, and kind of see that this is the point where on the graph they would be intersecting 1, 2, 3, 1, 2, 3. And I will bet you that this is a point where they intersect or cross, whatever it looks like. Of course, I don't have it perfect right there. You can take a look. So thank you all, and we will come back for our last video about the different methods where we will look at elimination, which is the favorite of many folks who love to work with puzzles and kind of find some shortcuts. So I will see you all soon.